So, since today is super easy, and it's one of the top 20s, I'm going to go off to the side and just tell you, here's a top 20 question that is just like what we're doing today. And it boils down to one skill that I've taught you so many times by now. Let me think. There we go. This is what's called a rational function. It's basically a big fraction, and it's got math on the top and the bottom of the fraction. But if it looks just super confusing to you, you're not alone. But if you think about my favorite saying, if you can factor it, you should. If you get it factored, this thing is easy. Did you figure out the top was x plus 4 and x minus 4? Did you figure out the bottom would also factor like that? Take a second, finish it off. So for today, all they're asking you to do is simplify these, which basically means factor them and cancel stuff. And that is a top 20 skill. It's this problem right here is right off the top 20. Did you figure out it was x minus the 4 and x plus 1? If you got that wrong, double check yourself, because the outside and inside need to total up to negative 3x. Then this and this will cancel, and this is important. It's easy to just forget about them when you simplify it down and just say it's x plus 4 over x plus 1. That is a correct answer. But the fact that this disappeared created a hole in the graph. That's one of the things we'll deal with more later on in this unit, is you can't just act like this is exactly the same as this. That one had a weakness for positive 4. Because see, if I put a 4 in here, it'd make it 0 on the top and the bottom. And this one doesn't have that weakness anymore. This function has been like cleaned up. So it doesn't have any issues with positive 4. All right, so the one is simplified, and in the past, when we've simplified things, we've always just said they're equal. Like, would you agree that 4/8 simplifies to 1/2, and they're just simply equal? They're the same thing. Whereas this is not the same thing as that. They're different. Because this one has a weakness for positive 4 that this one doesn't have. So they're different. It's simplified, but it's different. That's the first time that's ever happened for you. Normally, if you simplify something, you just get it to be like, oh, that's exactly the same as that is. This is not exactly the same as that is. Do you get what I'm saying? Because this one here, right in this area and in this area, if you put a 4 into it, the function would die. Whereas this one, if you put a 4 in, it doesn't die at all. It just becomes 8/5, which is no big deal. Okay, so it's a little more complicated what we're doing than the top 20. I want to take another minute for top 20 skill, though. Do you remember this kind of problem? I called it clear the fraction. See if you still have a short-term memory. We did this last week. Do you remember how to clear the fractions out? In one step, you could do something that makes this problem go from really hard to really easy. Vaughn, do you remember what to multiply everything by? No. All right, I'll remind you. You want to clear the fractions out. That's a fraction. Well, why is it even a fraction? Because it's got a denominator. Just for a second, would you agree that if I didn't have the 3 and I didn't have the 8, this would be a super easy equation? 4n plus 1 equals 2. I mean, that'd be super easy, wouldn't it? You just subtract 1 and you divide by 4, you'd be done. So what makes the problem complicated is there is a 3 and an 8 there. So you multiply by 3 and at the same time by 8. Now, some people would say that's multiplying by 24, but I think it's better because it's factored. And let me show you what happens. Well, this is really easy. It's 2 times 3 is 6 times 8 is 48. That's just 48. This one distributes the 8 times 3 here and here. And times it by 1 doesn't really do anything, right? So, and now that I've distributed my 8 times 3, look at how cool this is. Cancel, 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 cancel. 8 times 4 is 32n, plus 1 times 3 is 3. And look at that. And if you can't solve this, you're in the wrong class. That's just basic algebra. So what's the key? The key is clearing out the fractions. That is a top 20 skill. Maybe we didn't talk about it in your hour. I think I must have talked about it in the other one because everybody in here is just like feeling like this is new. Do you get from here? It's just subtract 3. I mean, everybody can do it from here. And divide both sides by 32. That should be super easy for you. So how do you turn a problem from a hard one to an easy one? By clearing the fractions. This will come back in calculus. That's why it's important to learn it now. Is you'll use it in pre-calc and you'll use it in calc whenever there's complicated fractions. So I'm going to baby it down. Nice, easy numbers. Clear the fractions out and then solve it. If you start by subtracting 2/3, you didn't even hear what I told you. Clear the fractions. Then you won't have to deal with subtracting or adding fractions anymore. They'll be gone. So, what clears the fractions? Jackson, times by what?
Multiply everything by 2 times 3.
Yes, I like how you said that. You could have said 6, but you said it smarter. And I'm just going to skip the distribute and do it right away. Distributed it on that side, so they each get a times 2 times 3. And then this cancels this, 3n, plus that cancels that, 4 equals 4. 2 times 2 is 4 times 3 is 12. Super easy. Do you agree that made a hard problem easy?
Should we put n equals a over 3?
Yep.
Or?
That's it. All right, so I wanted to take a minute for top 20 stuff because this day is so easy today. Everybody go on to this slide. Simplifying fractions isn't even on the top 20 because it's too easy. So I like to make it into multiplies though, because you know my favorite saying, if you can factor it, you should. So you turn this 8 into something times something, and you turn the 56 into something times something, and then you cancel stuff, and that's the great way to simplify. Is 7 times 8 56? Is 8 times 1 the same as 8? And then doesn't it become obvious that it's 1/7? See how quick that is? If you just factor the top, factor the bottom, cancel stuff. You noticing a theme? Factoring. It's like every day in here. That's why I wanted to start the year with that basic 20, which had a lot of little simple factoring. All right. Factor the 12. Patel. What times what? 1 times 12 works, but do you get 27 isn't going to have a 1 or a 12 in it? I mean, it could have a 1, but then what would I even have done? I still got 12 sevenths. So how about something different than 1 times 12?
3 times 4.
Okay. Now, did you think about the 3? It was good strategy if you did, because there's a 3 in the bottom also. And then they can cancel, so it's 4/9. Do you get how it all comes down to factoring? This class is like factoring. Knowing that there's factoring in everything. Not everything, but a lot of things. What do you do if there's only a 1? Well, you do 5 times 1, because the bottom is going to probably have more. 5 times Stretch and you can do it. 12, good. And don't forget the negative. Cancels. Negative 112. All right, and D. There's a lot of things that go into 54. You can do this either of two ways. You can say, like, 2 times something makes 54. I know that must be true. Or I can just go with, well, I know 9 and 6 works. Just start with something. And then see if on the bottom, if there's something that would also work nice there. Like, ooh, 6 goes into 24 also. And then you just figure out 6 times what? I guess it's 4. Now, I could have used the fact they were both even, and said 2 times something, but it wouldn't have reduced it all the way. So you're smart to use things that would make it reduce all the way down. So 9/4. If I hadn't reduced all the way, I would just have to reduce again. So it isn't that big of a deal. But 9/4 is reduced all the way. By the way, in the old days, they called these impropers, because that makes you think, oh, that's not an okay way to do that. That's not proper. But yet we leave it that way. Don't make this into a mixed number. Because have you ever seen 2 1/3 n? No, you haven't. And you never will. You know what I mean? Like, you don't use mixed numbers in algebra. You use these. So I think whoever named this improper, that was not a smart name, because we use them all the time. They're totally proper. If I had 9/4 n in a problem, that's totally okay. But I would never have, well, what would the comparable thing be? 2 1/4. I would never have 2 1/4 n. Never see it. So I think improper was a bad name for those. Because 9/4 is it. It's done. Okay, so rational numbers can be written as fractions. I'm going to say that one more time. What's a rational number? A number that can be written as a fraction. Rational numbers can be written as fractions. These are all fraction problems, so they're called rationals. They're called rationals. Whenever you hear rational, I want you to think fraction. See how they're all a big fraction? All right. So, can I just cancel these? Yes, you absolutely can. But do you get that it's slightly different when it's done? Remember, the top one had a weakness for 5. If you would have put a 5 in this function, it would have died. If you put a 5 in this function, it doesn't die. So this is different than reducing with simple numbers, because you're actually taking a problem that had 2 weaknesses. Now this only has 1 weakness. There is a way to still make the bottom 0, but it doesn't have 2 weaknesses like the first one did. Okay, so I hope you get this is a little different. All right. Is 3x plus 1 the same as 1 plus 3x? Well, not exactly the same, but couldn't you rearrange it and then it would be the same? And so you can cancel those, yes. And then here's a classic wrong answer. Kid gets this left, and they're like, well, I can't cancel the x squared because there's no x squareds on the top. If you can factor it, you should. That x breaks up into an x times an x, and then you might realize that those can cancel. There's your final answer. And weirdly, it's simplified, but it's not the same. Because this function had a weakness for negative 1/3. If you had put that into this function, you would have got a 0 on the bottom and the top, and it would have died. But this one doesn't have that weakness. So it's simplified, but different. Okay. Not every fraction is rational. You're not supposed to have square roots in the denominator of a fraction. Did you know that? Did you know you can't really do this? If you didn't know that, you can't divide by something that goes on forever and never repeats. Think about what this really is. I'm going to make a crazy statement. Nobody knows what the square root of 2 is really equal to. And I know some math professors are like, I know what it's equal to. Okay, well, have you ever seen it? Well, you could sort of make a representation of what it could be like with some obscure triangle, but it's a decimal that goes on forever and never repeats. That is called an irrational number because it's like pi. Nobody has seen pi all the way out. It's a decimal, it goes on forever, never repeats. So moral of the story is you can't leave answers with square roots in the denominator. Or can you? Okay, let me explain. This is called it's kind of a technicality. So here's what I've found. On the calculus tests, they allow you to leave answers like this. So on AP Calc, which is a lot of you guys are going to take, not next year, but the year after that. A lot of guys will take AP Calculus. They allow this. It's okay. But weirdly, on like the ACT test, they don't ever leave an answer like this. And in a lot of textbooks, a lot of schools across the country, they don't allow the kids to leave it like this. So it's kind of like one of those weird, like, there's debate about whether this is okay or not. So I just need to show you how to fix them in case you need to fix them, like on the ACT test. It's called rationalizing the fraction. Watch what happens when I multiply by the square root of 2 over the square root of 2. Would you agree that effectively I just multiplied it by 1 because they're the same thing on the top and the bottom? And yet what happens on the bottom is all of a sudden the square root's gone. Because what is the square root of 2 times the square root of 2? It's the square root of 4. And what's the square root of 4? 2. I get this. Doesn't that look different? And yet it's equal to 1 over root 2. All right, you don't even understand why these are important right now, but I know where you're going. And in pre-calculus, you end up with this all of the time. You know why? Because you have a triangle that looks like this. The sides are 1, 2, and the square root of 3. Does that ring a bell? Do you remember that triangle from somewhere? It's called 30, 60, 90 triangle. We use it a ton. And if you do on a 30, 60, 90, you do tangent of this angle, TOA, opposite over adjacent, you get this. And what did I just say about that? It's up for debate on whether or not that's allowed. On the ACT test, nope. You have to fix it. You have to rationalize it. On the not a SAT, sorry. I'm not actually sure about them. I would guess they also make you rationalize it. But on the AP Calculus test, they actually say to leave it alone. Because if you try to rationalize it and you do it wrong, they'll mark it wrong. But they don't require it to be rationalized. Okay, so if you wanted to, though, you'd multiply by what things? Yes? Yup. And that makes, final answer, Maddie? Root 3 over square root of 9, which is 3. Perfect. That's an okay way to write it because this the weird thing that's on the top, the rational, that radical, that square root that doesn't work out nice is on the top. Now that's okay. And I get why there's debate. Like either way you have a square root in your answer. It's just in one case you're dividing by a square root and in the other case you're not. All right. So moving on. If a kid was stuck on this, it would probably be because they just can't figure out how to factor it. But I think we've done enough factoring that you'll be able to factor this. Heck, on our last test with there was so much factoring that by now you'd know it if you don't know how to factor. Ray, can you shut that door over there? Give you a chance to stretch your bag out. Carter, can you slide over so you can get out? There you go. Bob, yeah, what'd you get on the top? Let's do this one.
I canceled out the x squared, so it was negative 2x minus 4.
Let's not cancel anything yet. Just one thing at a time. Just factor the top for me.
Okay, x plus 3x minus 5.
X minus 5. Okay, double checking that to make sure you're right. That's negative 5x, that's positive 3x, that makes negative 2x, and that's what we wanted. Yay. Okay, and then factor the bottom for me.
X plus 3x minus 2.
Double checking it. 3x, negative 2x makes positive x, which is what we wanted. Sweet. Cancel, cancel. And remember, this answer is different than the original. The original had a weakness for negative 3. If you would have put a negative 3 here and here, it would have ended up being 0 on the bottom. But this one doesn't have that weakness. It's improved. There's a thing called CRISPR, gene editing. They think that someday you'll be able to edit your genes. Then this is a whole new world. Like right now, if you want to, you can pay a doctor to sequence and figure out what your DNA is saying about you. And you might be able to go for this like $1,000 test. They can go, oh, looks like you might have a weakness for this, and you might get cancer someday, and you might end up like benefiting from this drug might really keep you from getting, Alzheimer's someday. And would you want to know if you were going to get cancer someday? What if it was something you could prevent? Then I think you'd probably want to know. What if it was something you can't stop? I probably wouldn't want to know. Although, what if you were able to know that you were going to die at age 50? Would you live different? I'd live different because I'm 56. but like, okay, let's say I knew I was going to die at age 60. I would live different. Now, maybe we shouldn't. Maybe we should be living like, like you're going to die tomorrow kind of thing. But at the same time, I do think it'll be interesting. Dilemma over time. Okay, so editing genes is kind of like this because this doesn't have the weakness anymore. This one had a weakness for negative 3, and it doesn't have that weakness anymore now. It's still got a weakness. If you feed it a 2, the function's going to die. All right. Now let's get this one factored. Should be pretty easy. Macy, factor the top. X plus 3, x minus 3. Way harder to factor the bottom. But I think it's a factor by grouping, isn't it? So you can group this up and go, okay, out of this part, I'm going to factor out a 2x squared. And out of this part, factor out a negative 3. I hope they both come out to x plus 3. Anybody verify that? Okay, good. Then, on the bottom, I now have an x plus 3, which is the thing that's going to cancel, and a 2x squared minus 3. These cancel. Is it exactly the same as it was? Nope. You used to have weakness for negative 3s. Now you can put in negative 3s and it won't kill the function. It's been edited. So what if you can realize, oh my gosh, I have a predisposition to getting this kind of a cancer, and then what if they could edit your genes so that then you can't get the cancer? That'd be kind of cool. It might happen someday. Okay. Move on to this page. It's just more complicated because they lead with a negative to see if you know what to do with that. Top's easy to factor. Now, I would like encourage you to think about what is up here, that x minus 2. The teacher's going to probably want there to be an x minus 2 on the bottom to cancel with that. You know what I mean? And also, there's a 2 here. I bet you if you factor out a 2 on the bottom, then you'd be able to cancel that, right? So that's some clues. I bet you if you're factoring this, that you'll end up with a 2 that comes out so that it can cancel. And I bet you'll get an x minus 2 also, but there's no guarantee of that. Just kind of like an educated guess. All right, so did you factor out a negative 2 in the front of the bottom? Because see, there's a negative 2 in all of them. And I know you may not have used a negative, but you should have. Because your lead term of what's left needs to not be negative anymore. It needs to be positive. There, I factored out a negative 2. And then these 2's can cancel. That negative is still there though. And I bet there's still a chance that this thing's going to have an x minus 2 in it. In fact, if I was factoring it, I'd just start out with my 2x and my x, and then I'd go, I bet you it's a minus 2. You know, to make it cancel. And then I'd think, well, what would it have to be? Well, it would have to be a negative here to make it come out positive 2. And I bet you it'll work. Double checking. Negative 4x, negative 1x makes negative 5x. Boom. Yes. And I just dropped my negative. Oops. It's still there. Cancels. Cancels. Brings up an important point. If there's nothing on the top, is there really nothing on the top? What's on the top? 1. So final answer, 1. And that negative, I'm going to bring it to the top. It's okay to have it on the bottom. I just think it looks better on the top. Remember, this is the first time in your life where simplified is not equal to the original. The original had a weakness for 2's. If you had put a 2 in, I would have got a 0 on the top and the bottom, and that would have killed the function. This one doesn't have that weakness anymore. It's been edited. All right, cool. So, I do like this one. It's kind of cute. This is the last one, and it's just complicated factoring. So we got a chance to practice a little bit of the top 20 stuff, which are super important. 20 problems. If I can get you through them, even if you leave me for second semester, which this is the time of year when I start thinking about that, in mid-January, it's like a month from now, about half of you guys will go get taught by somebody else for second semester. But if I can get you through that top 20 and you can be like solid on all those basics, then I know you're gonna have a good second semester. classic mistake. If you left it this way, you done messed up, even though you did it so well. Why? Doggy, do you know why? What's wrong with my answer the way it is? Don't know. It's okay. You know what's that wrong, Jackson? The 3x's do not cancel because this is a positive. I'm sorry, it's being added to something, so you can't cancel the 3x. Yes? You can factor out an x. You see what's left? They both have x's in them. And when you factor out that x, you've got an x on the top and the bottom that are both in a times problem. So they're factored. So then these can cancel. Final answer, x squared plus 3 over 3. And I get why people want to cancel those 3's. It seems so tempting, but on my computer screen, or on my keyboard there, you cannot cancel those because this is part of an add problem on the top. So that's your final answer. Is it a rational function? Yes, because rationals can be written as fractions. That's the whole point. This unit is called rationals because a rational number can be written as a fraction. It's a fact. All right, you've made it to the end. So we do have extra time left. Why? Because, well, we're going to start the homework and you have a test to get back. Quite a few guys did really well on that test. It was really impressive. I will say I did note in the thing I sent out, people that had a bunch of missing assignments, it was pretty dramatic. If you had a lot of missing assignments, the best grade, it was like almost everybody that had missing assignments had a worse grade, like dramatically, like at least 10%, sometimes 20% worse than the other kids. I'm not saying the people that turned in all their work were perfect. I'm not saying that, but their averages were totally different. So do your homework. Okay, so let's do the first problem off of the worksheet. Lou, can you read me number 1, please?
X plus 2 over x squared minus 1.
I feel like it should factor. What do you factor the bottom to, Lou?
X plus 2 and x minus 2.
And when you do that, something cancels. And that's dangerous because kids often just think the answer is x minus 2. But there's a 1 on the top. So it is still a fraction function. 1 over x minus 2. And again, for the first time, your answer when you simplified is not the same as the original. The original one had a weakness for negative 2's. If you fed this original one a negative 2, it would die because the bottom would be 0. But this one can eat a negative 2 and it would be fine. You're going to learn that that's called having a hole in the function. This one, no hole. So it's a little different. This one still has a weakness. Its weakness is for 2's, but it used to have a weakness for negative 2's also. All right. Does it ask you for anything more or just say simplify? Does the direction just simplify? Okay, good. Now let me see the rest of this thing so I can tell you which ones to skip. Scroll up, is that all? Is there no second page? Okay, cool, thank you. I'd say that we can skip 11 and 12 and you would be just fine. So skip 11 and 12. I bet you'll still probably finish this puppy, or at least close, before you leave, as long as you're good at factoring. And that's all I got for you for today.